Great. Uh, I believe you had a wonderful session with Shakti. So where he had laid the foundation of what is AI and how we have come up to this current stage. The next talk by mine could be like building in a simple AI agent, nothing so fancy. It's going to be a simple AI agent that we are going to build today from scratch. I think we can get started. So the problem statement is we are going to build an AI agent to handle our to-do task items. So it's going to be a task manager agent, which helps us is going to add a task or helps us to add the to-do list of items. Also tracks which are all completed. So these are the three going to be the three functional requirements. So the AI agent should be able to add a task, should be able to list down the list of the tasks, and also based on the user input, it should be able to mark the task as completed. So the application is going to be a simple command line based application. The chart interface is going to be a simple command line where the user is going to enter all his messages in a chart in the command line, and the responses from the LLM is going to be also from the CLI. It's going to be a CLI based UI. So let's go to the thing. Uh, so just a recap on what is an AI agent, right? So as mentioned, AI agent is a simple computer program that has a definite objective. So it is a textbook definition. So it just understands the input, surrounding input, and it comes up with an action plan to achieve a certain the expected goal. Um, so to break down with our problem statement, right? Our goal is to track the list of to do items and also track and also add the items that is entered by the user. Uh, so the perceived environment is actually the input from the user, and the action is like what are the what is the expected based on the user input. The AI agent will be kind of making the specific action. Like if the user wants to add a specific task, then it performs that action, or if it wants the task to be completed, does the specific action. So the tools that we are going to be used, like it's obvious, is Python for the language. And for the LLM, we are going to use a local LLM using Olama. So just a brief introduction of what is a local LLM, right? So how many of you are aware of what is the local LLM? Anyone want to tell us like what is meant by a LLM, that local LLM? Like how would it differentiate? How would it differentiate different from the Chat GPT that is run in the cloud? Yeah. Yes. 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 So the local LLMs are nothing but you can just run the LLM in your own local machine. So you need not, use third-party LLMs like the Chat GPT or Gemini, which runs in cloud, and you need not pay for this LLM that runs local, because it uses your own computer's machine power to run it your machine. So as mentioned, this LLM is not going to be as performant as the large language model that is found in the cloud, like the Gemini or the Chat GPT. It's not going to be not that performant, but because it is basically a compressed version of this large language model. Uh, and it's all very smaller in size. That's why you can run it in a local, and it is also cost effective. So because you need not pay additional amount to the third party services, and you can also run it in offline, because you know the as this LLM run in your local machine, you need not have an internet to make a call to the LLM. And also it guarantees data privacy, because like whatever the data that is entered, that you kind of sent to the LLM is kind of within resides in your own like local machine, and doesn't get to any third party server or cloud. So just a brief. So I think this is the Olama website where you can kind of download your models, and there are like bunch of models that is kind of present. So you can kind of download here. And for our UK use case, we are going to use this Pen 2.5 model for our use case, and we are going to just run it locally now. So the first goal for us to run it is like we are setting up the Olama and local and running Olama in local, and a simple Python program to call the Olama model. So Olama is nothing but a open source tool that kinds of downloads this local LLM into your machine, and it can and it also provides a set of APIs which you can interact with the local LLM. So Olama I've already installed it, so maybe we can I'll try to run it in my local. I think it depends on the model that you are picking up. So uh, so so basically you need at least 8 GB of RAM in your machine and a good CPU for us for at least to to run the Olama in your local. Yeah, it could be an 8 core. So yeah, yeah. So if the model that you pick is kind of larger in size with many billion parameters, then you need to have a corresponding machine like that. Yeah, yeah. Yes. I think you can see it here. So you see it here, there are the parameters that is mentioned, right? The 7B, 3B, all of the parameters that is available. So 5 bill, 5, 5B is a 5 billion parameter, and it also mentions the context size that is present. And so you can see the size getting increased based on the parameters that is there. Yeah, you need a that much big machine. Yeah. So I've run Olama in my local. So it's running the Quen model. So if I give say so I think we got a response from the Olama model. And maybe we'll start with a simple Python code just to see like how we can interact with this model. Uh, so I think for a first task, we'll just write a simple. This is a simple function that will call the Olama API to get the expected output. So this is a function where we are just telling the prompt as like explain about India. And so we are specific. So so Olama it kind of runs in a local as a server. So we are hitting the particular API, generate API, and we are specifying the parameters like what is the model that we are using. So which is like when the model that we are using and the prompt that whatever that is being passed. And we are just sending a post request. Let's see what is the response that we get. It usually takes a bit of time based on the amount of text that you generate. So so it gives you a brief, information about like what is in there. So basically, what we have done is we are running a LLM in our local machine, and we are trying to get the interact with the local machine using the API that is available. Any questions till now, folks? Okay. Yeah. Um, sure. Let's go to the next. So I think the goal one we have achieved. So next thing, so we want to build a chart-based interface for this. Any thought like how we can build a simple chat interface that can interact with the LLM and get the necessary output? Any suggestion or solution that you can think of? That gives a solution? Yeah, of course, of course. That is the right solution. So what we are going to do is we are just going to build run a implement a simple infinite loop that runs infinitely, gets the output. Gets the user input, pass it to LLM, and gets the output, and shows the result until the user types the keyword quit. And yeah, so I think this is the program. I think we have already see the call LLM function, which interacts, makes an API call to the Olama, and gets their output. And we are so this is a new thing called run agent loop. So as mentioned, we are running it in an infinite loop. We are getting the user input, and if the until the user types the input as quit, we are just making a call to the LLM and getting the output. So yes, now we got a response from the output, and maybe I can yeah. Mhm. Is it visible now? So yes, so I mentioned my name is SAO, and so I'm getting a response from the output. Now let us check if it remembers my name, right? So now it is we are in the same chat conversation, but if you see the output now, it doesn't know my name. So which means it doesn't have any memory on its own. So let's see how we can build this memory, so that it understands, like so that it knows what is the conversation that we are having, right? uh, uh, so basically, so how we can kind of implement memory? So do you guys have any thoughts, like any idea like how we can bring in a memory to this chat agent? Now we have a infinite loop running that gets the messages from the user, and also gets also based on the user input, we are getting an output from LLM. So do you have any thoughts or suggestions like how we can uh, maintain this chat conversation? Yes, yes. So that's what we are going to do. So what we are going to do is we are going to store a previous chats in a simple array. But there comes a problem, because like the now the LLM needs to understand the difference between the message that the user sent, the message that the LLM has responded back, so that it can kind of gives an accurate response, right? So that's where something called a chat template comes in. So chat template is nothing but a simple syntax that an LLM understands in such a way, it kind of understands like what this message is about and who has sent this particular message. So each of the conversation has multiple roles, so that the LLMs can differentiate between the message that is sent by the user, the message that is kind of sent by the LLM, or just like a system level message that is being sent, right? And each LLM has its own syntax structure for this chat template. So for example, it's going to be something like this. So this is a Python code that we are saying like the use. So here the role we have there are two components here. One is the role, other thing is the content, right? The role mentions like what just gives a context on what who has sent this message, and the content is the actual message here. So in this case, we have mentioned the user as role, which is like we are mentioning that this is a user sent message, and the assistant is nothing but that was a response from the LLM. So basically, when you send this array into some kind of into the OLLM API, right? What it internally does it? It kind of converts the structure to something like this syntax structure, which kinds of it is kind of which helps the LLM to understand like what is the role and the what is the role and each of the message that is part of it. So this is the syntax that the LLM expects, and so this is something the array that is sent from the user, and internally the OLLM APIs convert to this syntax and send the message to the LLM. So there are three different roles with regards to the chat template. One is the system role. System role is nothing but you are setting a kind of system level message or a context to the LLM, basically defining the like how to behave to the user message, or setting the tone, or putting the constraints like you just need to behave in 2 words or something like that. So for example, here you could see so it says like you are a helpful assistant, and that always replies a short and clear sentence, which kinds of gives you the overall context on how the LLM should behave. And the user role is nothing but the as we saw previously, it is nothing but the message that is sent by the user, and assistant is nothing the messages that is sent by the model. Now let's look at an implementation. So we have the same API. So I'm just going to skip this function because this is the same thing that we have saw previously, or just like making a call to the LLM. And now we have as you could see, we have an array here where we are kind of storing all the conversation history. And if you could see here, I'm just setting a system role stating that assume you are required and provide an answer to the user as an haiku. So whatever the user inputs, I want the LLM to respond as a poet, giving haiku poems, and I'm just setting a role as a user, and I am mentioning that explaining about India, right? So previously, when you see the response was a very large sentence about like what is India about, and it was giving a much details about India, right? Now let's see how the output comes. See, if you could see, now if you see, it just returns a poem. So because you have sent the system message, you said a system message as behave as a poet and give me a haiku as a response. So whatever user related message that you put, it always responds in a haiku format. Now this is interesting. Now let's plug this into our chat interface. So now if you could see, so this is the same thing. So I'm just skipping it out. So we have an array to store all the conversation history, and it is the same infinite loop. But if you could see, so we are kind of adding the history of conversation that the user has made. So We are putting the role as user and adding the user input in the content. And similarly, whatever the result that comes to us, we are just appending that to the conversation history as a response from the LLM. Now, if I run it, now let's ask the name, which we did previously. Now it knows because we are sending the conversation history to the LLM and it understands that the user has already mentioned the name as SEO. Now, so now does it fit our problem statement, right? Now we have a good chat interface that is running. Can we try to see like whether it achieves our goal of adding a task? Let's give it a try. So it says, yeah, I have added the task. Go to gym to your task. So do you like to? It gives some additional messages. Yes. Now again, I'll ask it. I'll ask it to add another task. Okay, it is able to add a task. So now it is able to respond and say like it knows understands like these are the list of tasks that needs to be done. Um, yeah. Now are we good with this solution? Do you see any problem with this solution? Because this thing kinds of it solves a problem statement. Do you see any problem here? Yes. Yes, that is one problem. Yes. Yeah. I think one more person. Yes. That is a good question. So let's try that. Let's try that. Yes. So it started hallucinating. So it's giving a random answer. So yeah. So it has kind of missed out the task that we don't have. Uh, yeah. So now let's try to fix this out. So I think there are two problems. Like you already mentioned like the task is not persisted, and that could and we also need to store all the conversation history somewhere so that it has a context, and we can also make the output a bit predictable and structured because sometimes when you run for adding the task, it gives you a different output. Sometimes it doesn't. So uh, so the previous response that we got was different, but now you see it is giving a random answer, so this kind of start hallucinating, so it is not the expected output that we have. So any idea how we can solve so let's go one problem after another. Let's see how we can make the output a bit structured and predictable. Any thoughts like how we can solve this problem? Any ideas? Okay. So to get a consistent LLM output and to avoid a bit of hallucination, we can use prompt engineering. So what is prompt engineering? Anyone So I believe everyone has an idea of what is prompt engineering about. Yeah, please, can you? Yes, yes. So prompt engineering, nothing but you are constructing the input to the LLM in such a way so that you are getting the expected output. So there are different multiple techniques which you can engineer the prompt so that the LLM understand like what is that you are kind of expecting out, right? So I think there are four elements to a prompt engineering. So one, so the instruction is nothing but you specifying what is the goal that you want to achieve. Next is the context. Context is nothing but a set of putting out a background or giving additional information or about what or additional information about what the how to achieve the goal. I mean how the goal is to be achieved. And persona role is like you want the output to be in a certain point of view, and format or constraint is nothing but you are expecting the output in in a JSON format, or you want the output limited in 100 words, or in 2 sentences, something like that. So this is an example that we have. So if you see, write a persuasive product description. If you give that alone as an input to the prompt as an LLM, right? So it doesn't understand what the product is all is about, and it could kind of give you a random description about any product. To set the context, right, we are given additional information of the product is durable, reusable coffee mug made from recycled material. Now we are giving an additional information about setting a context like how the LLM should behave to generate the output, which makes it more sense, right? Now to understand, like you need to do a product, give a product output for a product description for a reusable, reusable coffee mug. And now you want to put a role. You're giving a role as a marketing copywriter, right? So now we understand like you need to provide the output response as a copywriter, and also and the next is the output. So you are expecting it to be a short paragraph, and also you are setting the tone of how to do be, so which is like upbeat and inspiring, and like you are not expecting the words to be more than 100 words. Like you are just setting the constraint to be. Now with this thing, it should be easier for us to the LLM to provide the necessary output of what you're expecting. And there are a couple of tips that you can try to do. So one is like the prompt should be very specific and direct, without any unwanted details. So, and it also have details on what is the expected output. Similar to how we humans talk, right? If you are talking to someone person, and you're sugarcoating a lot of things, and you kind of deliver the message at the last, somehow the other person kind of misses the message and observes only the sugar coated topic that you get, right? Similar way, you need not add this all additional things. You can just say, for example, in the above prompt it says like, I need a little help with something, could you write a short summary of a topic for me? So this is really not required, because this actually kind of confuses the LLM. So because the context kind of switches between whether what does the user really need, right? Whether he needs some kind of a help, or should he kind of read wants to write a short summary topic for him. And the second part is like, if you see the first prompt, it doesn't specify what topic it is. So the LLM kind of hallucinates and kind of it writes a random topic. So if you see in the next prompt, we are just giving what is the kind of expected thing, right? And we are kind of also very specific about it. So summarizing the key benefit of solar energy for homes in a 3 sentence paragraph, which makes it much more clear for the expected output. And the next thing is like you need to inform the LLM of what to do, instead of what not to do. So for example, if you take this, right, so you are kind of creating an app for a movie suggestion, and you are asking not to ask the user about the personal information. When the user asks, please recommend a movie based on my interest, if you the output could be something like, uh, he doesn't know what kind of interest user doesn't know. So it says like, uh, it so we are explicitly mentioning that you should not ask about the user interest, but it somehow it does not able to understand that, and it asks like what kind of your movie like you to watch. So basically adding some this kind of a narrative use cases kind of confuses the LLM. and we need to be more specific and provide input on like uh, on positive scenarios. So if you see in this thing, the prompt, you're telling the AI agent. Uh, so if you see, the following is an agent that recommends a movie to a customer. The agent is responsible to recommend a movie from the top global trending movies. It should refrain from asking users for their preference and avoid asking for personal information. And also, if the user doesn't have any movie to recommend, you're telling, sorry, I couldn't find a movie to recommend today. So you're mentioning that for negative use case, just respond in this way and don't do anything else. Right now, the customer asks, please respond a movie. Now it gives you app response like, I don't have any information about your interest. So it gives you a different suggestion altogether. So another thing is like we can start with a simple prompt, and you need to iterate until you get the necessary output. So let's see how we can use this prompt engineering to kind of fix the first challenge of not getting the desired output. Any questions till now? Yes. You can, but again you need to design the prompt in such a way that if you don't, so similar to how this use case, right? Yeah, that you can do. So it could be something like, what is the capital of, if it stops, right? So if you just input like, what is the capital of, and you stop there, right? So LLM doesn't understand what to do, and it kind of gives a random output for this kind of thing. But you kind of engineer the prompt in such a way, stating that if the so you are a LLM that understands capital of all the countries. But if the user doesn't specify the country, please ask the user what is it. That is the prompt that you're providing, right? Now the LLM understands, like, you need not complete the sentence. You need to get the additional information from the user. Only then you can complete the provide the answer. Mhm. Cool. Any other questions, though? Okay. So let's see how we can use prompt engineering to get a better solution or the expected output for us. So we already have a conversation history array where we kind of store it right now, and also this function we already saw, like, which calls the LLM to get the necessary output. And now if you see, there's a now the prompt we have is kind of very big. So now we are setting a context to the LLM saying that you are a simple conversation assistant for the managing task. Your only jobs are to add new tasks, list existing or mark tasks as completed, and your output must be plain human-like text and should not contain any JSON or structured data. We are just mentioning like what is the action that we want, what is the thing that we are expecting, and what is the output that we are expecting. And we are also defining some of the rules and example responses for each of the commands. So if to add a task, so if a user asks you to add a task, confirm that you have done so. And we are also providing an example to this. So example user input add by groceries. Your response is got it. I have added by groceries to your list. And similarly for the to list task, we are mentioning the prompt as like the user asks to list the task, confirm that you have received the request. Example user input list my task. I am fetching your task. So this is a response that the LLM should respond like, okay, I'm fetching a task for now. And similarly to complete a task, if a user asks you to complete a task, confirm that you have marked it as done. Marked by groceries is done, and your response is like a marked by groceries is complete. For any other request that is coming from the user, which is the error case scenario, we are just telling that the user asks for anything else, politely inform them that you can only add list or complete tasks. Example user input, can you tell me a joke? I'm sorry, I can only help you manage the task right now. So this is the engineering prompt that is being engineered, and we are going to run the same agent loop. We are setting the context in the conversation history first, and then we are it is the same agent loop code. Let's run this now. Uh, so now with response like got it, I have added the go to gym to your list. So we are kind of so if you see here, this is a response that we are expecting, and that is the response we have get. So with the basic prompt engineering, we are kind of setting the or constraining the LLM to respond in our own expected way. And now I just I'll ask to add another task. And I will ask you to list the task. Okay, now it says I'm okay fetching a task for you, because that is that is the output that we are kind of expecting the LLM to provide. And similarly, can you yeah, so for the completer also, it is kind of responding in the expected thing that we have kind of set. So now let's test a negative scenario also, right? So it says like, so I'm sorry, I can help you only manage the task right now, because we already defined a prompt, added a prompt to behave like you just need to respond only to these instructions and not respond to anything else. And this and kinds of gives you this negative output of I'm sorry, I can only help you manage the task right now. So far so good. Now the first challenge of getting the output in the expected format is kind of completed. And now the next problem that we need to address is like persisting the task. So as we discussed, like one way, like you can maintain the entire conversation history and take it up and kind of load it out again. but the problem, as one of you mentioned, right? So the context window is very limited here. So what we can try to do is, instead of storing all the conversation history, we can kind of store only the task in a kind of JSON file, and retrieve the task when it is required, so that the task is kind of persisted. But now comes a problem, right? How does a LLM knows like how to store the JSON, in how to store the task in the JSON file? Any idea how we can kind of make the LLM understand that you need to make you need to kind of write your task in a JSON file? Any thoughts? Yeah, that is one way. Yeah, yeah, something like that. Yes. So I think the tool calling would work for sure. Like, I think we can go to the next thing, but for the starters, right? We can what we can try to do is we can we can ask the LLM to send the response in kind of a JSON, in a structured JSON format or a expected schema, so that we know based on the output we can take the necessary action for this. So we will request the LLM. So using the prompt engineering, we will request the LLM to kind of send the output in a JSON format, and we could write a custom logic to kind of take the necessary action here. So basically, the flow would something like this: the LLM would kind of send the output in a in a kind of JSON format that specify like what action to take, and based on that action, this perform function has a if else statement, and based on that action key action in the JSON schema, it would kind of make the function call to create a task, complete a task, and list task. And internally, this would kind of call an internal function called save task and load task to kind of add it in the JSON file. Uh, so this is on a very high level. Let's see how in the code it is kind of implemented. Sure. Yeah. So we kind of provide a prompt in such a way such that we kind of so we are basically try asking the LLM to infer like what the task could be. But as you mentioned, it could also be kind of wrong. It could be any textual data that could also get inputted, right? So there could be there's a fair amount of chance that error could happen. But for this use case, we have this. I would say this prompt is not a fail-proof one, but so for a simple thing, it could kind of work as expected. You can. So for this use case, it is not very 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 intelligent enough to do those kind of thing. So it's still dumb. We are going to making a bit tweak it a bit in there, but yeah. Yeah. So if you see, yeah. So we have tweaked the prompt a bit. So we are saying that your conversational task manager agent, your primary goal is to help the user manage their task. You understand the command to add task, list task, and mark task as completed. Query specific task or clear the task. You must always respond in the structured JSON format. So we are expecting the JSON format as a response here. So intent is going to be add task, list task, and complete task. And the task description is going to be string or null. And the response message is like what are the message that is going to be the user, right? Say for and we are also giving an example stating that if the user has to add a task, set the intent to add task and expect the add task description. If the user asks to list task and set the intent to list task, if the user asks to complete a task, set the intent to complete a task and extract the task description. So we are asking the LLM based on the user's thing. We set the intent keyword that is here to any one of the following, and based on the intent keyword, we will be taking the appropriate kind of an action here. Yeah. So now we have set the context, which is the base prompt that is there. The conversation history, and we are running it. And if you see, we have this perform action function. So what it does is like it gets the intent, and based on the intent, it calls this create task function. And it also we are asking the LLM to derive what could be task description here. So in this function, we are just loading a JSON file here, and then kind of simply writing that new task to this particular JSON file. As simple as that. And similar way, we are kind of doing it for the completed task. For the completed task, we are loading it, we are searching the task, and then we are kind of setting the status to completed in the JSON file. And similarly for list task, we are kind of loading the JSON file and kind of printing the task description and as well as the status. Now let's try to run this code. So say go to gym clear successfully. So it's able to create a task, and if you see, so it has created a task or JSON file with all the necessary information with the, what is the task description about and what is the status that is being sent, and we are kind of storing it here. So now when I close this application and I try to run it again, right? So it basically fetches the task from the JSON, and it kinds of loads the list of items, and now you see it is kind of persisted here. Uh, so this is one way, and next is like as you mentioned, we'll go to the tool calling implementation. How we can kind of avoid this the custom logic of perform action where we have nested if conditions through which we kind of pick the take an appropriate action. Instead of that, we will ask the LLM to decide on what action to take, and we just need to call that particular function. So next is tool calling. Tool calling is nothing but as we discussed above, like we kind of we can integrate an external be it any external API or function to the LLM, so that it kind of understand the relevant data. Uh, so one example could be like you can integrate an weather API to the as a tool to the LLM, and you can basically try to get the what is the latest weather, and based on that you can try to provide a suggestion to the user of taking umbrella or not, right? Because this weather information will not be available to the LLM, because because it is not there in the pre-trained data. The LLM has a limited knowledge, or it has only knowledge up to what on the data what it was trained on. If you ask any latest information, it wouldn't have the latest information, and it needs some kind of an external tool for us to get that particular knowledge out. So yeah, so let's run this code, or let's walk to the code. So now you could see the context is kind of simple. So you're telling your Conversational Task Manager API, you can add complete list tasks, use the provided tools to manage tasks. Now we are mentioning explicitly that you have a set of tools in your command which you can use to make the necessary actions here, right? Now we need to understand like how we can configure to the LLM to state these are the tools that are there in your command, right? Uh, so one way, so Olama, if you could see, so this is the Olama API that we make a call. So if you could see, there's an additional parameter called tool, right? So you're explicitly mentioning the LLM that hey, these are the set of tools that you are available. You can take it and use it if kind of required, right? Let's see how the tools is kind of defined here. So you're telling the tool is going to be some kind of a function that you need to call, and you are just giving a brief schema of what the function is about, right? Say it creates a name is like you are giving a name, and you are giving a detailed description of what the particular function is used for. Creating a new task with description uses when the user wants to add a new item to their to-do list. And similarly, you are giving like what is the expected thing for the create task. So we are expecting a parameter called task description, and it's kind of a string format, and we are telling the description of the new task to be just giving a description of what is the parameter about. So this create task relates to nothing but this particular function where I mentioned giving the where it is expecting the parameter as task description. And similar way, we have defined a bunch of tools for each of the functions that it needs to take. And now here comes a question to us, right? How does the LLM understand like which tool to use, right? So any thoughts on this? Okay. So basically, it tries to so the description that you give here, right? So basically, LLM tries to read the description, and based on that, it tries to infer like what tools that it needs to be called. Now, the previous implementation, this implementation, so we are explicitly stating that these are the external tools that is available to you, and we are also giving a brief description of each of the tools and what it does, and we are kind of giving uh, all the power to LLM to design on what exact tool to be called, right? Uh, and so that is how the tool happens here, and we have kind of defined the tools here, and we also mentioned the tool choice to be auto so that the LLM can design like what it does. And now it is the same kind of a loop, and similarly we have a perform function that is there. In this, what we does is we just try to get the LLM message, that is that basically if the LLM tries to use a tool, if the LLM expects a tool call to happen, right? The response could have something, the JSON response could have something like a tool call and the schema. And so the tool call is present, and we so in the tool call has additional detail like what is the function name and what are the arguments that is there. We get the list of things, and we basically kind of make the function call happen here. So here we have a map of functions that for each of the keywords that we have, we are just mentioning what is the task that needs, what is the function that needs to be called. And for each of the result that we have, based on the function name keyword, we are kind of calling the appropriate function and getting the result back and telling to the user. Now, if you see, we have kind of empowered the LLM to take a decision and kind of suggest us like what is the action that needs to be taken, instead of we deciding on what is the action that needs to be taken based on the LLM output. So now if you run it, so it says like I'm calling the tool. So to understand that a tool needs to be used, and it says like list task is called with the given argument, and we are getting the necessary output from the same JSON file. So this is a JSON file that we have used in the previous example, and we have not. So it is using the same task JSON file to get the relevant output. And so now it's understand like you are calling a tool called create task, and it's also able to derive like go to as alone is the kind of task description, and so says like you are calling the tool, and based on the response, we are kind of we are making a call to that add create task function, and we are kind of storing that uh, in the JSON file. So now it is done. Now let's. So again, it says like it understand like we need to mark a task as completed, and task description we are saying like go to hash alone, and it kind of says as completed. Now if you see here, so if you see the go to hash salon, this kind of says completed, and you can see a similar output here also. Yeah, good question. So with the current implementation, it doesn't understand that. So because with the existing implementation, what it does, it is able to infer that go to hash salon is a task, and internally the function what it does is it does an exact string match of the task description and this one, and it kind of adds like if change the implementation like go to the gym, then it doesn't understand, it doesn't work as I expected. Yeah, you can. So basically again you need to engineer the prompt in such a way so that it understands the list of tasks, and also it able to understand these kind of nuances there. Any questions folks, before we wind up? That's it from my side.